All right, so let's talk about DLL hijacking. This is the most common way malware gets execution on your machine, and it has to do with Microsoft's use of dynamic link libraries, which make code smaller and they make it run faster, but they're dangerous, so we're going to exploit it. And so you have to have a machine with Windows Defender disabled, and we're going to use the Metasploit framework, which, like everything else, is pre-installed here. So the first thing we're going to do is create a malicious DLL. So to do that, on this machine, the Metasploit framework is here. So it's C:\Metasploit framework, bin, and the MSF Venom tool is the one that writes malware on Windows machines. So I'm going to put out, this is the exploit I'm going to do, Windows x64 shell bind TCP. This will just start listening on port 4444 by default, and anybody who connects will be able to remote control this machine. That's a simple kind of malware. I want to make a DLL, which is a library file, instead of an executable. And let me I think I have to see, yeah. Then I have to output this thing. So I'm going to do output, and I think I'm going to put it on my desktop and call it shellbind.exe. There, shellbind.dll, pardon me, there. There. So that should create a file on my desktop called shellbind.dll. There it goes. Metasploit is written in, I think, an interpreted language, Ruby, so it runs kind of slow. I'll take this time to clean up some junk off my desktop that I don't need anymore. All right, and looks like it printed it on the screen instead of putting it in the DLL file. So apparently I made some sort of mistake. Let me see if I can figure out what I did wrong. I got the command here in the instructions. It certainly ran Metasploit.
There's a dash, space, and then the output.
Oh, there is. Well, you're right. I'm missing the O. Thank you. Good. Good. So I need an O here, which is how it output. Good. All right. Let's see what that does. Because this is the, you can, by the way, see this is printing out an executable. Here's the name of the API calls and such. So it's printing it on the screen instead of putting it in the file is all. Good. All right. Good. There it is, shellbind.dll. Good, thank you. Now, all right, and we want to make sure the firewall is off. It probably is off on this machine, but let's make sure, because it'll block network connections like the kind we're going to need. Check firewall status, perhaps. Yeah, it's off. Good, okay. All right, now we're going to check. We're going to find our target, and our target is going to be a Microsoft service that isn't used much. So we open Services, and there's a thing called the Distributed Transaction Coordinator here. And if you read this, this is something to do with connecting to databases on a database server. We're not using it. All right, so let's go into the properties of this and see the Logon tab. Currently it logs on. This one's set to log on as the local system account because I've done this before. Originally it was something else and I changed it to local system, but for this project we just want to run it as local system. All right, so I click OK, and now I can view the DLLs in Process Monitor. So this process, by the way, Distributed Transaction Coordinator, is running, and so I'm going to stop it. It's currently stopped. Okay, right now it's stopped. This is what I want. I wanted it stopped at this point. And we're going to use a tool we haven't used before, Process Monitor, which is extremely helpful. Process Monitor is a tool you use to analyze malware. And here you can use it to find vulnerabilities. That's procmon. There it is, procmon64. What this does, it really just harvests the data from the Windows log files, but it picks out things of interest, and you can filter it, which is what's really important because the Windows log files contain far too much information. So what I'm going to do is configure these two filters. I want the process name. I wonder if I can edit this. I'm just going to remove these old ones then because they're not right. All right, I'm going to add another one. Okay. And what I want to add, oops, I see. It confused me. All right, I want to make process name contains MSDCC. So it's process name contains MSDTC. Okay, so I'm going to add that one. And then I want path ends with DIL. So path ends with probably, that first one would be enough anyway, but anyway, I'm going to put this one into .dil. All right, so now I'll only see events that are caused by the MSDTC process. Now I want to start that process, so I'll click OK, and this should be running. Yep, there it is. There's Process Monitor running, and see, it's already picked up 163,000 events, but none of them appear because they don't pass my test that they have to come from that msdtc.dil thing. So now I'm going to launch it here, and we should see what happens when it starts. So it was on the third page down, Distributed Transaction Coordinator. I start it. There it is starting, and you see a bunch of things happen when it starts. So it's loading, and all these events are happening as a result of starting this. And I think that's probably enough. I'm going to stop this sniffing, which I think you do here. Capture. There, I think that stops sniffing. This is good, and now I can see. And what I'm looking for here is a library load that failed. So we want to find the OCI.dil operation that loaded. Oh, I see. That's why I made path end in DIL. Over here is the path. And see, this is showing me all the library operations. So this service starts, it loads a bunch of libraries, and down here someplace, it's going to load something called OCI.dil. And I could configure a filter to just find it, but it shouldn't be impossible to find it by just scrolling through. There's MTX OCI. Here it is, OCI.dil. Okay. Now, this DIL was not found is what I want to see. There, I should see a name not found in results. But instead I'm getting some kind of file locked message, which is disturbing. Which makes me think I may have fouled up this machine. File locked with only readers. I may have somehow fouled up this file on this machine with previous demonstrations. Makes me a little nervous. But anyway, on your machine, I think you'll see the expected result, and I'm not quite sure what's going on with that machine, where you see name not found. And the point of this is a very common flaw in software of all kinds, of Windows software, is you're including a library, and the library is no longer present in some later version of Windows. So this is and so it's not, it doesn't find it. The OCI.dil doesn't exist. And when that happens, it makes it possible to perform the attack we're going to perform by adding an OCI.dil program. So let's see. All right. So let me position the malicious DIL. And this is probably why this happened. The old malicious DIL is still there. So let me just try this again. I'm going to check to see if an OCI.dil is in the Windows System 32 folder. If it is, it's a malicious one created by me in a previous demonstration. So let me just do a directory of C, Windows, System 32, OCI.star. That's it. That is a malicious file. And you can tell because it was created in 2022. And this is Windows 10, all the files would be much older. So I'm going to delete that file, which is a malicious file I created and left there from previous demonstration. So delete. There. Oh, I got to do it in an administrator command prompt. There we go, because meddling with system files is, of course, something you can't do. But actually, now I'm in the System 32, so I can just do delete OCI.dil. And access is still denied. That's annoying. I'd have to elevate myself to system to delete it. All right. Well, I'm not quite sure. Oh, probably because that process is running. Let's get the distributed transaction coordinator, and I need to stop it. All tasks. All right, I seem to have made a mess. Okay, I think I'm going to have to restart my machine is the way I'm going to have to do this to get rid of that malicious file. Let's try that. And this, by the way, is another reason why you do all these things in a virtual machine you can throw away, because messing with the operating system and the files at this level, you can easily trash your machine. But I'm hoping a restart will stop that process, which was in a sort of broken, halfway started condition, and give me a chance to delete that file. All right. Let's see if I can delete that file from an administrator command prompt now. Now, it is possible to delete files and get to a system prompt, but I'm hoping I don't need to. Now it let me do it. Okay, now I should be able to repeat the previous activity, which is run process monitor. Okay, and the filters should already be in there that I need, and they are. Okay, I'm looking for all the libraries loaded by MSDTC, so I say OK, and this should be running. Okay, now I start that MSDTC thing in services. Distributed Transaction Coordinator, start. And now it'll probably start quickly. There, it's done starting. If the reason it took so long is because it hit that bad library. And now it stopped sniffing and I'm seeing them. And now I should be able to see how it loaded OCI.dil, and it'll be kind of obvious because it'll show name not found. There's one that was not found, edge DI, and there's another. There it is, OCI.dil name not found. So the point is, this service was compiled requesting a library, but it never used that library. So when you port it to another version of Windows, it runs because it tries to load that library, it doesn't find it, but then it turns out it doesn't need it. It never uses it. This is an error that happens quite commonly in the complexity of software development, but it means if I put a fake file there, it will just load it because, once again, Microsoft loads this stuff without having a signature or anything to verify it. So all we have to do is take that malicious DIL we made and put it in that location with that name. So let's have an administrator command prompt. All right, and now I can first stop that service. I could have done it in the services panel, but you can do it from the command line to its net stop msdtc. Now I'm going to, it's stopping. Okay, there it's done stopping. Now I'm going to put that file from my desktop into this folder. So it's copy my file, which is C users student desktop, and it's currently called shellbind.dil, and I'm going to put it in this current directory, C Windows System 32, with the name oci.dil. Okay, and now let's start Process Monitor again. All right. With the default stuff there, and it is now sniffing for events. This is good. And now I'm going to start that process. Net start msdtc. Okay. And now you'll get a different reaction with oci.dil. It should load the malicious oci.dil, and I should be able to use the shell. So let me open another command prompt window, and now I should be able to do a netcat to ncat on Windows 127.0.0.1.4444, and now I get a system command prompt. Notice I'm not the administrator, but now I'm in C Windows System 32, and if I do who am I am now system. So I have elevated myself from non-administrator all the way to system by hijacking this process, which runs as system, and it's listening on this shell. By the way, also notice this broke this MSDTC because these malicious libraries made by Metasploit are pretty sloppy, and they just hijack the execution when it loads the library, and the program does not proceed beyond that point. But anyway, this is a simple way to do it. Now, I'd like to clean off that DIL. It's in the project. This DIL, as you can see, is kind of messing up my machine. So the simplest thing to do is end this task. You can do that in Task Manager. If I hit Control-C here, it might stop it and it might not. But I should be able to delete it. One way I did it in the project was with Resource Monitor. And with Resource Monitor, I'm able to find the process listening on 4444. On the Network tab, listening ports are down here, and I should be able to find 4444 here. Oh, I'm looking at the PID. Here's the port number. Okay. I'm not finding it. I may just have to restart the machine to unlock these things. All right. TCP, all right. Let's see, this is still connected. If I exit, all right. And does that free this? I don't think it does. So I might be able to stop this in services. Probably the only way to get rid of that file is going to be to restart the machine. It's difficult to get these various processes that are using it to let go of it. But let's see. I'll see if I can stop the MSDTC in the services panel. Yeah, see, it's all sort of frozen and halfway running. So now the only way to clean it up is what I did before. Restart the machine. And then I'll be able to delete that malicious DIL. So that's what I wanted to show you. That's a useful project. I should just mention, as I mentioned, this process it has some serious disadvantages. You have to find a library that's loaded and never used, and when you add this malicious DIL created by Metasploit, it freezes up a process because it's pretty sloppy. So if you want to do a better job, you do this process, DIL proxying. And with this one, you actually make a copy of a real system library, and you make a proxy DIL that will actually forward all those functions to the real system library, so it has all the functionality of the genuine DIL and malicious functionality added to it. So this way you can hijack a library and have the executable that uses it continue to run and add malicious code to it. So it's much more powerful. It's a little more complicated though. So check out that project if you want a more clean, effective version of this attack. But this one shows the basic problem with these libraries. So I'm going to stop that recording.